Okay, dear students, we'll start our lesson. Today we talk about the review of probability theory part. Because so far we have finished probability theory part. From the next lecture we start statistics. So let's recap what we have learned in probability theory part. Let's start with this exercise directly. In exercise 13 it says traffic light. When arriving at the traffic light closest to the author's home, there is a 25% chance that the light will be red. So here's the question. It says, express the indicated degree of likelihood as a probability value between 0 and 1. We need to express this percentage into probability value. So in order to express it, we need to divide by 100 this percentage. So given 25 percentage, and in order to make it probability, 25 divided by 100 gives us 0.25. So P equals to 0.25 for exercise 13. In exercise 14, it says, while this exercise was being created, weather.com indicated that there is a 20% chance of rain for the author's home region. 20% of rain, the chance of rain is 20%. So we say P equals to 20 divided by 100, which is 0.2. This next question, exercise 15 says testing. If you make a random guess for the answer to a true-false test question, there is a 50-50 chance of being correct. So true-false question will be like this here, the question text, and the answers true and false. You have two choices. Either you choose this one, either you choose this one. So this is equals to 50 over 100, or it's better to write 50 or 100 also. Okay, we can write this because it gives to us 50-50. If we add them, we'll get 150 divided by 100 gives us 1 over 2. But in case, it's also like how many choices we have according to this rule, m over n. So how many choices we have? We have 2 choices. How many? We are allowed to choose one of them. So 1 over 2, which is 0.5. In this case, also 0.5. The school children in exercise 37 gives us an interesting question. Use this simple space listing the 8 simple events that are possible when a couple has 3 children. It says there is a couple with 3 children, and these 3 children can be in different order, like boys, girls, like for example, triple B, 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 and G, B, G, B, D, double G, G, double B, G, B, G, or double G, B, or triple G. In this case, this means like BBB means boy, boy, and boy. Like BBG means like boy, boy, and girl. Like there are 3 children in a family, so the eldest one is boy, the middle one is also boy, the younger one is a girl. So we need to assume that boys and girls are equally likely, so that the 8 simple events are equally likely. Here's the question. The last line asks to find the probability that when a couple has 3 children, there is exactly 1 girl. We need to find the probability m over n. Again, n is 8 because like 1, 2, 3, 4, 5, 6, 7, and 8. N equals to 8. And m, 3 children, there is exactly 1 girl. 1 girl is here. Let's choose this one. 1, 2, three. Okay, we have three cases, three array. This is the probability. If we divide this, we got like 0.375. 0.375. This is the probability that we were looking for. The next question in exercise 38 says, using the same sample space and the assumption from exercise 37, so use this one again, find the probability that when a couple has 3 children, there are exactly 2 girls. When a couple has 3 children, there are exactly 2 girls. So again, we need to use like probability n, m over n, just n is 8, m, 2 girls. Let me change the color of my pen to the blue. Okay, 2 girls. Here we have 2 girls. Here we have 2 girls, and here we have 2 girls. So it's also 3 over 8, which is 0.375. In exercise 39, tells us, in exercise 47, list the sample space for a couple having 3 children. First, identify the sample space for a couple having 2 children. Then find the probability of getting 1 child of each gender. Again, assume that boys and girls are equally likely. So for 2 children, we may have boy, 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 girl, girl, boy, girl, and girl. So probability equals to m over n, which is n is in our case it's 4 now, and we need to assume that boys and girls are equally likely and find the probability of getting 1 child of each gender. So the first one and second one, 2 over 4, which is 1 over 2 gives us 0.5. In exercise 40, we need to identify the sample space for a couple having 4 children. For a couple having 4 children. For a couple having 4 children, we need to find the probability of getting 3 girls and 1 boy. So it will be a huge number here. For a couple having 4 children, boy, 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 and girl, boy, boy, girl, and boy, boy, girl, boy, and boy. Here you have 4, girl, boy, 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 girl, boy, boy, girl, girl, boy, girl, boy, girl, girl, boy. Now like boy, boy, girl, girl, boy, girl, boy, girl, boy, girl, girl, and boy. How many we have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We need more because here we have 4 children. So if we have like 2 types of genders, boy and girl, 4 children gives us 16. We need 5 more. And 3 girls and 1 boy. Girl, 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 boy. Girl, girl, boy, girl. Girl, boy, girl, girl. Boy, girl, girl, girl. And girl, 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 girl. So we have 16 now. We need to find the probability. And our n is 16. And first identify a sample space for a couple having 4 children, then find the probability of getting 3 girls and 1 boy. 3 girls and 1 boy. 3 girls. How many? We have 3 girls. 3 girls. Let's choose. This is the first one. 2, 3, and 4. Just 4 cases. So 1 over 4. 0.25. We identify the probability. And it says, what is wrong with this expression? Here we have an expression, P of A plus P A bar equals to 0.5. P of A bar, which is complement event. The event plus the probability of an event occurring and the plus probability of event complement occurring equals to 1. We have studied this before. It's equals to 1. It's not 0.5. So this is wrong in this exercise. The next question says, we need to determine whether our events disjoint. Arriving late for your next statistical class, arriving early for your next statistics class. So late and early. You cannot have both at the same time. You cannot came early and late in the same class. So this is disjoint. Disjoint. Asking for a date through a Twitter post. Asking for a date in French, the Roman language. This is joint. These two are disjoint. Now we need to identify independent and dependent events. Exercise 5 says, exercise 5. When a month is randomly selected and ripped from a calendar and destroyed, it is July. So we have a calendar like this. This is a calendar, and there are 12 months there. 12 months there. We choose one and destroy it. It's July. So how many left? 11 left. It says when a different month is randomly selected and ripped from a calendar again, it is November. So first time we choose out of 12, next time we choose out of 11. So these are dependent. Dependent. When a baby is born, it's a girl. When a second baby is born into a different family, it's also a girl. Independent. Because it says different family and next birth. So it's independent. Exercise 7. When a baby is born, it's a girl. When a single die is rolled, the outcome is 6. Independent. When a day of the week is randomly selected, it's Saturday. So we have days of week like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So we choose one, it's Saturday, okay. I will choose one, this one, this Saturday. When it's second different day of week, now I will choose again, like, this one, it's Monday. Independent, because it doesn't matter. When a second different day of the week, but it says different day of the week. So we close this one and choose from other, so it's dependent. Describing complements. We need to write complement of event. The exercise 5 girls. When a couple has 5 children, all 5 are girls. So 5 children. We have 2 types of genders, boy and girl. So they have 5 children. We have 32. 2 to the 5 gives us 32. So all the possible ways 32. Times they can have all 5 girls, just one. Wait. So the probability of A equals to like 1 over 32, or the event A, all girls, event A bar, which is complement, at least one boy, just 31 over 32 we have. When a couple has 5 children, none of the 5 is a girl. None of the 5 is a girl. It means none of the 5 all boys. Hey, all boys. Which is none of 5. None of them girls. A bar. At least one girl. Versus in China. In China, the probability of a baby being a boy is 0.545. Many couples are allowed to have only one child. Among the next 5 randomly selected births in China, what is the probability that at least one of them is a girl? Can this system continue to work indefinitely? So now we have to consider like baby being a boy and girl. So the probability of a baby being a boy is 0.545. Boy. 0.545. Probability of baby being a girl 0.455. And the question says, what is the probability that at least one of them is a girl? At least one of them is a girl. So there is a formula for at least one event, which is 1 minus q sub 1, q sub 2, it's q sub n. Probability of at least one event. So q's are non-occurring of the event. Like we need at least one girl. So q is not being a girl. So it means 0.545 q. All q's, because each time it's the same China. P equals to 1 minus 0.545 to the 5. Because we have 5 verses. So we need to calculate this number. Zero point 445. Take sign of the calculator to the 5, which is equals to 1 minus 0.048 equals to 0.95. If we talk in percentage, we can have this in a percentage 0.9. This is probability. This probability in percentage, we have to multiply this by 100 percentage, get 95.2 percentage. This should be 5. In percentage language. Next question says, the probability of a randomly selected car crashing during a year is 0.0423. If a family has 3 cars, find the probability that at least one of them has a crash during the year. Is there any reason why this probability might be wrong? So we need again use the at least one event. At least one event. It says probability equals to 0.0423, and we need opposite event formula here. So as you may see here, 1 minus 0.0423 gives us 0.9577. Now we need to use the formula. P equals to 1 minus, it says 3 cars. Look here. 3 cars and at least one crash. At least one crash. So 0.9 to the cube. To the cube. If we got 1 minus 0.878 equals to 0.1270. This is in probability notation. In percentage, 12.1%, which is the 12%. If a family has 3 cars, so at least one of them will have a crash during a year. Now it's 12%. The next question says, what does the symbol exclamation mark represent? In this one, this is factorial. Factorial. In mathematics and probability theory, we call this factorial. 4 different people can stand in a line 4 factorial different ways. 4 factorial means 1 times 2 times 3 times 4, which is 24. ATM PIN numbers. A thief steals an ATM card and not randomly guess the correct PIN code that consists of 4 digits, 0 through 9. That must be entered in the correct order. Repetition of digits is allowed. What is the probability of a correct guess on the first try? ATM, I think you know what is ATM. An ATM PIN numbers consist of 4 digits here, like 4 digits. First 4 digits. For each case, this is like PIN code. So for the first one, you can choose any number from 10. For the second one, for the third one, for the fourth. So just multiply them together. You got 10 to the 4. But all possible ways. And correct one of them correct PIN. So probability calculated, P equals to 1 over 10 to the 4, which is 0.01. Harry Potter books. There are 7 books in the Harry Potter series. If the books are read in a randomly selected order, what is the probability that they are read in the order that they were written? So 7 books. We have here 7 books of Harry Potter in the bookshelf. Like the third one, first one, second one, fourth one. 7, 6, and 5. There are 7 books of Harry Potter. So if you read, what is the percentage that you read or probability in this order? 4, 5, 6, and 7. So first you will choose out of 7. Next you choose out of 6. Out of 4, 5. Next you're allowed to choose out of 5. Then out of 4, 3, 2, and 1 last. So this is all the ways, so which gives us 7 factorial. Probability equals to m over n equals to 7 factorial. The correct order is only 1. Just in one case, you will read that in the correct order. So 7 factorial gives us 5,040. 1 over this one. Classic counting problem. A classic counting problem is to determine the number of different ways that the letters of Mississippi can be arranged. Find the number. So first of all, we need to calculate how many letters we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, we have 11 numbers. 11. Because we can arrange these numbers in 11 factorial ways. 11 factorial ways. And we have to divide by the number, by some number. Why? Because we have here 1, 2, 3, 4. 4 C's. We have 4 C's. And I's. We have 4 I's. And we have double P. So we have to divide by 4 factorial of S's and then I's, and then 2 factorial of P's. So this is equals to, we can cancel them. 1 factorial, 4 factorial, we have here 5, 6, 7, 8, 9, 10, 11. Divided by 4 factorial, 1, 2, 3, and 4, 2 factorials, 1 and 2. We can have like 2, 4 gives us 8, 2 and 3 gives us 6. So we have 5 times 7 times 9, 10, and 11. Let's calculate this number. Which is 34,000. 650. And exercise 14 is the similar. You can solve this in a similar way. And the author is creating this exercise where the report stated that there are 3 chances in 10 of rain today. What is the probability of no rain today? So probability of rain is 3 in 10. Probability of no rain equals to 1 minus P, which is 1 minus 3 over 10, gives us 7 over 10. This is the probability of no rain, which is opposite event. In a day of the week, if a day of the week is randomly selected, what is the probability that it is a day containing the letter Y? Let's write down the name of days. We have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, containing letter Y. We have Y here, Y, Y, Y. So the probability of selecting is 1, which is certain event. This is certain because each day has letter Y. Based on Harris poll, 20% of adults smoke. If 2 adults are randomly selected, what is the probability that both smoke? The probability of the first adult smoke is like 20%, which is 20% is 20% equals to 20 over 100 gives us 0.2. 20% for the next one is the same, so we use like 0.2 times 0.2 gives us 0.04. The probability that they both smoke is 0.04. In Orange County, 51% of the adults are males. It doesn't take too much advanced mathematics to deduce that the other 49% are females. 1 adult is randomly selected for a survey involving credit card usage. We need to find the prior probability that the selected person is a male. Then it is later learned that the selected survey subject was smoking a cigarette. Also, 9.5% of males smoke cigarettes, whereas 1.7% of females smoke cigarettes. Use this additional information to find the probability that the selected subject is a male. The prior probability, which is 51%, 51% equals like 51 divided by 100 gives us 0.51. In probability notation, probability equals 0.51. But it says in the question B, this is the answer for the question A. In the question B, it says the selected subject was smoking a cigarette. So we need to calculate what is the percentage of this subject is a male. Here we have to use bias theorem, bias rule. Let's denote like M as a male, C as a cigarette smoker, M bar, female or not a male, C bar, there is the bar, C bar, not a cigarette smoker. Before using this information given in the part B, we know only 51% of the adults in Orange County are males. So the probability of randomly selected an adult and getting a male is given by PM 0.51. And we know PM bar 0.49. 49% of the adults are females. Male smoke cigarettes like 9.5%, which is 0.095. Female smoke cigarettes 0.017, which is 1.7%. Now just apply this formula, the bias theorem. We got a 0.85. Before we knew that the survey subject smoked a cigarette, there is a 0.51 probability that the survey subject is male. However, after learning that the subject smoked a cigarette, we revised the probability to 0.853. There is a 0.853 probability that the cigarette smoking respondent is a male. This makes sense because the likelihood of a male increases dramatically with the additional information that the subject smokes cigarettes. Mean and standard deviation. In order to find mean and standard deviation for the numbers of girls in 10 verses, in order to find mean, we have to calculate like mean, mx, which is mathematical expectation, like multiply this together and add them like 0.001 plus 1 times 0.010 plus and etc. And then in order to find standard deviation, which is we use sigma x squared minus mx squared. We got this one first, then we calculate mx squared, which is 0 times 0.001 plus 1 times 0.010 plus 4 times 0.044, etc. And calculate mean and standard deviation for this one. This is the mean and standard deviation for the numbers of cars that failed among the 6 cars that are tested. When an adult is randomly selected with a replacement, there is a 0.85 probability that this person knows Telegram and the other questions. Here we have M&M's, set questions, brown eyes, and the last one. What is this? What do you think? This is the chair or sofa of an airplane. Why do we need this? Why do we use statistics? Statistics are probability theory calculated the average numbers, but there are no average people in the world. Everyone like a little bit greater than average or a little bit lower than average, so there is no average person in the world. So first we calculate the average, and it's always normal distributed. Sorry, it's not normal. Like normal distributed like this. So we know like 65% of people average mx plus sigma and mx minus sigma. Mx plus sigma is this point, mx minus sigma is this point, which is 65% of people will fit here. And another here, 95%. 95% of people will fit into this place, which is mx plus 2 sigma plus 2 sigma mx minus 2 sigma. So because of that, we can find the numbers that contain average, and it contains 95% of people in the world. So we can create the chairs or sofa for airplane. which will be comfortable for all people. This is the end of lecture. Good luck, guys. Take care. I recommend to attend next lecture